Guys, we're going to still be talking about quadratics today. We're going to start looking at a different form. And in section 3.3, we're going to be calling this graphing f of x equals ax squared plus bx plus c. Now, guys, we've taken a look so far at ax squared. And we've taken a look at ax squared plus c. So my question is today, what's different? The b value in here, right? This bx part right here, this is going to be the part that we look at that's going to be kind of new for us today, all right? And what I want you to understand today is this. We need to be able to answer how can you find the vertex of a graph of the function ax squared plus bx plus c. And in order to do that, we're going to have to graph some quadratic functions of the form ax squared plus bx plus c. And then we're also looking at finding maximum values and minimum values of quadratic functions, okay? So what we're really exploring today is what impact does this b value have, or how do we manipulate b to help us answer these questions right here, to find a minimum and maximum. So let's get rolling on some vocab first. First term I have is maximum value. And the maximum value is going to be what, kids? Okay, and for our purposes in this section, we're talking about quadratics. So the maximum is going to occur when we have an arch right here, okay? So we're going to be looking for that arch, but that point there still is the what, kids? Still the vertex, isn't it? Okay? Well, kids, if we're going to be looking for a maximum value today, we're also probably going to be doing what else? Looking for a minimum value, right? Looking for a minimum value. The minimum value is going to happen when our graph is what shape? A U shape, okay? I still argue this should be our school's logo for Union. Okay. And then, guys, just a couple of terms that we've talked about a lot in the past. We really haven't talked in terms of this. We usually talk about them as input and output, or x and y values. But you're going to hear me talk a little bit about independent variable in this section. What's it say the independent variable is, kids?
The x value.
Yep, the x value, or usually the value input. Okay, and that makes the dependent value the y value or the output value. Okay. All right, kids, here's the big idea today. This core concept right here, this is super duper important today. In fact, so important, I'm going to kind of highlight this. You might want to put a star or something by it. Yeah, this is a really important core concept, okay? All right, kids, we're going to talk about this form of quadratics today. And guys, the thing I want you to understand is this. First things first. Any quadratic function that we have that's written in standard form is always written of the form y equals ax squared plus bx. Anybody want to guess what's on the end? Okay, the thing I want you to understand is this. A, B, and C. A, B, and C are some number. Okay? A, B, and C are going to be some number. All right? So when we get into this more today, I'm going to say, okay, kids, if this is standard form, what's your value of A? And what's your value of B? And what's your value of C? We'll talk about that here in a little bit. All right? So, some things you need to understand, and this is kind of what you're going to come back to every day. Guys, I won't get into why right now, but the line of symmetry right here, kids, the line of symmetry is going to be of the following form. And this is an important formula right here. Okay? This is going to be x equals the opposite of b, so the opposite of b over 2a. Okay? It's going to be the opposite of b over 2a. And we'll talk more about that here in a little bit. Now, keep in mind, kids, does the line of symmetry pass through the vertex or not pass through the vertex? Okay, so to find the vertex, I'm going to make a note here. Use x value of the line of symmetry to get, to get your y value. Okay, and I'll show you what that means here in a little bit. Okay. And anyone know what my favorite thing is about standard form? They're going to ask for a y-intercept. And you want to know what the y-intercept is? The y-intercept is just the c value. That might be the prettiest c I've ever drawn in my life, kids. That is a good c, isn't it? Average. I like that c. Okay. So kids, I'm going to tell you right now, this core concept right here, this is kind of your rule sheet for the things that we're going to do today, or the things that we're going to find, all right? But the most important one to you guys right here, you can't do any of this unless you know line of symmetry. So I think in this box right here, put a star here, that's going to be mucho importante. Where are my Spanish-speaking people? Mucho importante, did I say that right?
Yeah.
Okay. Sounded good, didn't it? All right, kids. Let me ask this question. Just double check. Do you have everything down as I have it up here? Are we cool with that? Okay, anybody need more time? Let's get into this. Okay. Guys, the first thing it says we're going to do is find the what in example 1? Going to find the axis of symmetry. Okay. So let's just do this. I'm going to abbreviate up here, LOS. I always put LOS. I call it a line of symmetry all the time, but just understand. Axis of symmetry or line of symmetry, they mean the same thing. All right? They simply mean the same thing. Guys, what's our formula for finding the axis of symmetry? What did we put up there in that core concept? Yep, so it's the opposite of b over 2a. So let's do this first, kids. Let's identify our a, b, and c values. In this function right here, 2x squared minus 4x plus 5, what is your a value?
2.
2. What's the b value? Be very careful on this.
-4.
Yep. I always think it's important when you're doing anything with quadratics, especially that of the standard form. I think it's always important to write your a, b, and c values. What's the c value here, kids? 5. Okay, good. All right, to find the line of symmetry, kids. The line of symmetry has a formula. It says it's that value, x, or that line, x equals opposite of b over 2 times a. Well, kids, based on our a, b, and c values, what the heck is the opposite of b up top?
4.
Okay, so b is -4, so what's the opposite of -4?
4.
Yeah, it's going to be +4 up there. So my line of symmetry will be the following. X equal +4 over 2 times a. Well, kids, what the heck is our a value? 2, right? So we're going to go 2 times what in the bottom? All right, well, what is 2 times 2 in the bottom, kids? And now this really becomes 4 divided by 4. Where's our line of symmetry?
1.
Okay, so guys, we have a line of symmetry at x equals 1. I'm going to circle that right down here. All right, our line of symmetry right there, x equals 1. Okay. Well, our job then is to find the coordinate of the vertex. Okay. Well, guys, the coordinate of the vertex is found by using the line of symmetry. Okay. And what value did we just get for the line of symmetry?
1.
Now think about this, kids. If I had a graph that did this, made a U shape, whoops. If I had a graph that made a U shape, doesn't the line of symmetry pass right through the vertex here? So what I need to do is take this x value and plug it into our function to get a f of x is kind of like a y value. Right? We're going to plug 1 in for x to help us find the y value. Why am I plugging x in to be 1, kids? Because that's my line of symmetry. So let's go on this vertex. To find the y value here, kids, we would say y equals. Anywhere where I have x in this function, what are you going to replace it with now?
1.
And I will remind you, anytime you plug something in for x, you should always put what around that value? Parentheses. So y is going to equal this. Okay, here we go. Here's my function. 2 times what's taking place of this x?
1.
2 times 1 squared, in parentheses, minus 4 times 1 plus 5. Now guys, this math is a little complex for me on a Monday morning, so help me with the y value. What do you get there?
Oh,
Let's see, wouldn't this part be 2 right here? 2 minus 4 times 1, which would be what, kids? What are you guys getting for a value for my y value? 2 minus 4 plus 5.
3.
Yeah, y is 3. So guys, what coordinate then? What coordinate is my vertex? What do we plug x to be in? 1. What do we get for an output? Input 1, output 3. Independent variable, dependent variable. What coordinate is the vertex going to fall at then? What comma what?
1, 3.
My vertex then is 1 comma 3. Whoops, not 1.3. 1 comma 3. And that, my friends, is how you find a vertex. But before I can find a vertex, we've got to locate what? Line of symmetry. And line of symmetry only works in, what's this form called again, kids? Yeah, and I probably should allude to this right here. I'm going to go back to the very top here. This form right here, ax squared plus bx plus c, you might want to write this down. This is known as standard quadratic form. And this is known as standard quadratic form. In fact, everything we've done has been standard form. We just didn't have a b value all the time, and we didn't have a c value all the time. Okay? So it's written as standard quadratic form. But before I find the vertex, what do you have to find? That is a good looking C. Holy cow. I mean, that's like Sesame Street worthy right there. Today's letter. Alright? I'm pretty pumped about that. Before I can find the vertex, what do I have to find, kids? Line of symmetry. Okay? Guys, I just want to show you this right here, just so it makes sense to you. Guys, I need you, I'm going to jump into decimals here real quickly. Help me out. In there, I know it started out 2x squared, kids. What was the original function again, kids? 2x to the...
Second minus 4x.
So, okay, 2x squared. Did you say minus 4x, Logan?
Yep.
Okay, quick question here. What did we say the line of symmetry was?
Yours is just 45.
Oh, that's not going to work, is it? That's a mess. Plus 5 or minus 5? Okay, where did we say the line of symmetry was again, kids? So if I type in x equals 1 like this, does that divide it in half? Is that an axis of symmetry? Does the left half mirror the right half? And what did we say the vertex was, kids? 1 comma what? Does that match? All right. Things that I like about this is, you know, I can come into decimals and say, ooh, I can just do it in decimals, or I can use decimals to know if I'm doing things correctly. I would hope you do the latter, all right? Okay, well, let's talk. First things first, any questions on example 1? Show of hands, how many are on board with me right now? All right, let's talk here. Example 2 then, kiddos. I like this one. So we want to try to graph ax squared plus bx plus c. And I've kind of set this up in a foolproof way. We're going to kind of do the same thing we just did. We're just going to have to follow the rules here. I'm going to call this step 1 up here. Call this step 2. Call this step 3. And then my graph will be over there. So graphing stuff right here, anything in standard form. If you can kind of follow this form right here, you're going to be in good shape. Guys, what's the first thing I tell kids you should probably do before you even start the problem? We want to graph x squared minus 2x minus 3, kids. Now we're also going to talk about the domain and the range here a little bit. We've talked about that in the past. What's the a value if it's just x squared out there?
1.
1x squared, isn't it? How about my b value? What's the c value? Yeah, Halloween party over there? What did we say this was? -2?
Yeah.
And then what here?
-3.
All right. That's the first thing I'm telling you to do.
Line of symmetry.
Find my line of symmetry. What's that formula for line of symmetry again?
X equals opposite of B over 2A.
So we're going to have x equals, what is the opposite of b, kids? 2 over 2 times what?
1.
That becomes 2 over 2, doesn't it? So line of symmetry, x equal 1. We all agree there?
Yeah.
So to sketch this right here, once you've got one part of this done, let's go down to our graph and draw that in here. So simply put, kids, you're going to come down here, you're going to be like, okay, Carson, and then I'm going to be like, yeah. You're going to be like, I'm going to throw that line of symmetry in at 1. So at the x value, what x value am I going to on the x-axis? 1, and we're going to draw a vertical line right through this, okay? And this will be the line that that parabola or our quadratic function is going to mirror right here. So I'm going to draw this line of symmetry right here. Oh, that's not a very good line of symmetry. I'll make that better and brighter. But at x equals 1 right there, that's where we're going to draw that line of symmetry. Does that show up better for you guys right there for line of symmetry?
Yes.
Okay, there's my line of symmetry at x equal 1. Okay? Now, guys, how do we use that line of symmetry to our advantage? What's my next step? What's my next step? Find the vertex. Okay, remind me how I find the vertex again?
You're gonna put the x value in for the.
Okay. So this is, if this is my function right up here, kids, what have I got to put in for x? 1. You got to put that value in. So my y value, or f of x value, y becomes equal to, all right, you guys help me with the math. What's 1 squared? Minus 2 times 1, that's minus 2, isn't it? And minus what other value here, kids? Okay. What's 1 minus 2? -1. -1 minus 3 more would make. So my y value is at -4, isn't it? Right? So my question then becomes this: if my input from the line of symmetry was 1 and the output from the line of symmetry was -4, what's that make the vertex coordinate? All right, so if we've done this correctly, kids, I might get lucky with this, but I would go right 1 and down how much to get to my vertex? I'm going to put that right here. Okay, so we've got our line of symmetry and our vertex graph. All right, that was step 2. What does step 3 say to do? What's your rule for y-intercept? Y-intercept is just a c value. The reason it's a c value is, what's my x value right here?
0.
If I would plug 0 in for x right here, kids, if I would plug 0 in for x here in this function, 0 squared would be what? 0. 2 times 0 would be, it's basically like these just fall out, leaving you with a c value of what? Well, the y-intercept is going to simply be -3. So what this says is this, kids. It says find the y-intercept and its mirror point. Well, let's go plot that y-intercept of -3. So on the y-axis, where am I going? Down 3, right? Quick question. Where's its mirror point going to lie?
3.
What specific coordinate?
2 negative.
Yeah, how far left of the line of symmetry is my y-intercept, kids? How much a distance right here? 1 unit, so it means if this is a line of symmetry, that's got a mirror to the right of it. How many units on that same horizontal? 1 over here. And kids, what you've done is you at least got a decent sketch. Your parabolas at least hit those points. Oh, I totally missed that. Yikes. Halloween must be getting close. That was a pretty spooky drawing. There is a good sketch of your parabola right there, kids. Okay? What's the first thing we're looking to throw in there, kids? Line of symmetry. Once you've established where the line of symmetry is, use the line of symmetry to find the vertex. Once you've located your vertex, onto the y-intercept and its mirror point. Okay? Guys, will my vertex be a minimum or a maximum in this situation? How about the a value out in front of x squared? Is it positive or negative? If it makes a u shape, should the a value out in front be positive or negative? Okay, let's talk about what's going on here. There's another concept that we need to talk about here. In example number 3. Oh, cow. Guys, example 2 there. How many of you are like, I think I can follow this order here and make this work? You guys okay with it? Okay. Well, all right, let's take a look at this next one then. All right. I like this a lot, and I'm going to make this as simple as I can for you. Okay. It says finding what and what, kids? Okay, the minimum or maximum value in any quadratic is always going to be, what point is this, kids? It's called the vertex, right? The vertex in this case is a minimum or maximum, kids? Minimum, okay? Well, right over here it says, how do you tell if one's going to be a minimum or maximum even before you graph it? So over here I've given you the condition that A is what, kids? Greater than 0. Okay. Guys, what is the A value in this? It's 5, right? Okay, quick question for you. If that's a 5 out in front there, will that make a U shape or an arch? It's a positive 5, it makes a U shape. And therefore, if this makes a U shape, will that point be a minimum or a maximum? So what I'm going to tell you up here in this condition says if A is ever greater than 0, then you will always have a minimum point. And so if A is less than 0, meaning, well, what is A in this example? -2. Then you'll have a what? Now guys, once you've identified minimum or maximum, to find the exact coordinate, you're simply finding the what? Vertex. And I can't find the vertex without finding the what? Line of symmetry. Okay, so Lexi and Andrew's table and Corbin and Sam, you guys are doing the left one. Find the vertex on the left one. Everybody else, you guys are finding the vertex on the one on the right. Okay? So before I can find the vertex, you have to find what for me? Line of symmetry. Once you guys have an answer in your groups, compare with each other, okay? So Lexi on over, you guys are doing the one if A is greater than 0. And Daisy to this side of the room, you guys have got the one where A is less than 0. I want you to locate that vertex for me. My God. All right, kids, help me out here. What's the A value on the left, that side of the room? This is kind of a toughie. What's your A value? 5. What's B? What's your C value? Okay, we need to know where this minimum point is. It's a minimum because A is greater than 0 or less than 0. A is positive, right? Okay, so let's chat here. Line of symmetry first, so the opposite of B. Yep. Over 2 times A, which would be what? I don't like this one because it doesn't turn out nice and even, but wouldn't that be negative 1.5, kids?
Yes.
Okay, so now if you have a calculator right here, here's what I'm going to suggest. When you're putting stuff into your calculator, I would type it just like this. The Y value then is going to equal 5. What am I putting in for X? If you put negative 1.5 in parentheses like this and square it, if you would type in exactly what I have right here after the equal sign, just like I'm putting it in here with the parentheses and everything like that, I don't know. I can try and do that in my head. Do you want me to? Oh my gosh. Okay, now you're challenging me now. That's not fair. So 2.25 times 5, so that'd be 12 point. Oh, lordy. 2.25, 10. Somebody take 10. So that's 11.25, right? 10. 2.25, 10. What's 1/4? 1 1/4. Negative. So it'd be 11.25 plus minus, so a negative 11.5. Do you get negative 22.5 when you punch that in like that? If you're using an iPhone, it might not do that for you. Okay, do this for me. Take negative 1.5 and square it. Do you get 2.25 when you do that? 2.25 times 5. Tell me that that's 11.25.
Yes.
All right, I've got 11.25 for my first part. What's 15 times negative 1.5? 22.5, good. Minus how much? On the very end. Minus 10, okay? When you punch that mess in, what do you get? Somebody run 11.25 minus 22.5 minus 10.
Negative 21.25.
So my vertex is going to fall at okay, what's the X value we put in, kids? Negative 1.5. Kind of stinks that everything isn't just really nice whole numbers, right? Negative 21.25. Okay. All right, so let's just walk our way through the B side, or the right side there. What's the A value in this example, kids? B? And your C value. Okay, we know that this is going to be a maximum because, yeah, the A value up front is negative. Okay, so this is going to be like an arch shape. Okay, so let's rock this here. What's the opposite of B going to be in this one, kids? Okay, so my line of symmetry, the X value for my vertex is going to be negative 14 over 2 times negative 2, right? Which makes us negative 14 divided by negative 4. Y'all know that a negative divided by a negative is still a positive, right? Oh, check me, but is that 3.5? Oh my gosh, it'd be positive, shouldn't it? So the X value is going to be 3.5. How do I use the X value to find the Y value? Put it in there. Okay, help me out, kids. This becomes negative 2 times 3.5 to the second plus 14 times what? Minus what? Okay, now I'm going to try and do this in my head, but you guys check in your calculator. Let's see, that's 12.25, so negative 24.5. 42 and 7 is 49. I got 23.5. Is that what you got also? So Daisy, help me out, kiddo. Where's the vertex going to fall in on this one? What point?
3.5, comma 21.5.
Very good, kiddo. Did you say 3.5, 23.5? That's what I heard, right?
Yeah.
Good. That's a 0.5 right there. Yeah, let me ask this question. How many are like, I understand the process? Okay, how many are like, I don't like it when the process kicks out ugly numbers? Okay, because then you're a little bit unsure. But guys, if I wasn't 100% sure that was right, what could I do now? Run to decimals and check and see if that vertex falls right there. Okay. All right. Now, am I saying use decimals to get just the answers, or am I saying use as decimals to make sure your work is correct? Use it so that you know that your work is correct. Very good. Okay. Confirmation. All right. Okay. Let's see. Any questions to this point? Line of symmetry, use it to find a vertex, determine maximum or minimum. I think you guys have this. Let's rock and roll. I like this example here. Finding a, what kind of value, kids? Kids, why do we know we're finding a minimum value here? Yeah, the A value is positive, right? So we know it's going to be U-shaped. Company plans to have coffee mugs. Ooh, cup of coffee produced with the company logo on them. Maybe that's what I need to have. Coffee mugs. We should have coffee mugs for everybody with our union logo on it. And we can have a flavor of the day.
Is that not a thing already?
Isn't it?
I thought that it was a thing.
I don't know. I have my coffee maker over there. All right. The cost of each mug depends on the number of mugs that are ordered and is modeled by the function y equals 0.0001 x squared minus 0.1x plus 30, where x is the number of mugs ordered and y is the cost in dollars. What is the minimum what?
Cost of each
Cost, right? Well, kids, if I'm looking for a minimum, we're kind of finding looking for the vertex again. So let's roll on this. We would have to find the line of symmetry, so x is equal to the opposite of b. What's the opposite of b, kids?
Positive
0.1. Over 2 times what? Is that 3 zeros after the decimal there? Lexi, am I seeing that right up there?
No.
Okay, so this becomes equal to 0.1. You guys agree this will be 0.0002? Somebody divide that out. 0.1 divided by 0.0002.
When I did that. Is 100?
What do you guys get?
500.
This is saying order 500 mugs, okay? But we want the cost of the 500 mugs. We want the cost of a mug, right? What is the cost of each mug? Oh, this is a tricky problem, kids. It says y is going to represent the cost in dollars of all the mugs. How many mugs are we ordering, kids? We need to know the total cost. Y would be a total cost then, right? Help me out, kids. How are you going to find the y value? Put it in for x, right? Anybody have an actual calculator instead of a phone, or I guess figure this out for me? I guess I can punch it in mine here. See what you get for a value when you punch that up. What do you guys get? Five? Okay, I'm getting 5. So what's the cost of each mug gonna be, kids? Yep. Y is 5 when I do this. So the cost is $5 per mug. Guys, what I'm going to ask you to do before you come to class tomorrow, take a shot at example number 5 right here. See what you can come up with. We'll talk about this first thing tomorrow, but read through this, see what you can do, be prepared to talk about this a little bit tomorrow. I did send out a new online page, so make sure you start looking at that. It's like 10 problems long, okay? JMC and all that stuff, good to go on my end, so check that out.